All right, momentum. A few facts about momentum that you should definitely know. Momentum is a vector, meaning it has size and direction. We use momentum when we're figuring out what's going on in collisions between two objects. Faster objects, or things with greater velocity, have more momentum, and heavier objects, things with more mass, have more momentum. Pause if you need to reread any of that or listen to it again. I'm going on to the next slide. Formula for momentum is P equals mv. And since this is a vector, let's go ahead and write it as 1. The momentum vector equals mass times the velocity vector. Mass has the unit kilograms in this equation. Velocity has the unit meters per second. And momentum, P, since m is already used for mass, we use P for momentum, has the unit kilograms times meters per second. Which makes sense because if you do kilograms times meters per second, you get kilogram meters per second. Pause if you need to get any of that down. And then I'm going to go on to an example. Alright, first example. We're going to find the total momentum of this two-car system. A 1,500 kilogram car is driving east at 80 meters per second. An identical car is driving west at 60 meters per second. What is the momentum of each car, first of all? And then what is the total momentum of the two-car system? The reason I like this question is because we're going to use the fact momentum as a vector as we do this. So first, what is the total momentum of each car? Let's call this car 1, so it will have momentum 1, and this car 2, so it will have momentum 2. Car 1, if we think about our cardinal directions, car 1 is the one going west. The problem tells me it's an identical car going west at 60 meters per second. And since it's identical to the first, its mass is 1,500 kilograms. And notice it's moving in the negative x direction, so its velocity will be negative. Therefore, the momentum vector equals mass times the velocity vector. So the momentum of car 1 is the mass of car 1, 1,500 kilograms. And here we're using negative and positive to indicate our direction. And negative 60 meters per second. Just offhand, I think that should be negative 90,000 kilogram meters per second. So momentum of car 1, remember that harpoon on the top just means it's a vector. And the vector is mattering in this example, which is why I'm keeping it there to remind us all it's a vector. And we get equals negative 90,000 kilogram meters per second. So that's the momentum of car 1. Got that done. Now the problem says find the momentum of car 2. I'll use a different color just so we don't get confused. So the momentum is mass times the velocity vector. I'm writing the equations because on the AP exam, recognizing the right equation to use is usually worth a point. So go ahead and write your equations whenever you start a problem. Oh, I don't know why I wrote that one twice though. That would not be a point. So momentum of car 2 is 1,500 kilograms for the mass times 80 meters per second. And since it's in the positive direction, positive, and that should be P2 is positive 120,000 kilogram meters per second. Okay, that's the momentum of car 2. Now the problem says, what is the total momentum of the two-car system? Well, since we kept our directions using positives and negatives, we can just add them together. So total momentum, P total, is negative 90,000, the first one, kilogram meters per second, plus 120,000 kilogram meters per second. Negative 90 plus 120 is positive 30, and that's 1,000 kilogram meters per second. Positive, letting us know it is in the eastward direction. All right, Key takeaways: formula for momentum, P equals mv. Momentum is a vector, so its directions matter. Next example, we're going to try to make the total momentum of a system be 0. You'll see what that means when we do this example. Beetle A has a mass of 100 milligrams, oh goodness, some converting is going to have to be done, and walks in the positive x direction at a speed of 0.1 meters per second. At what speed must a 25 milligram beetle walk so that the total momentum of the system is 0? Let me zoom this slide out so we can see what we're doing. So first, like I said, we're going to need to convert those masses into kilograms because in the equation P equals mv, that mass has to be in kilograms. So let's go ahead and do that. 100 milligrams equals blank kilograms. If on the chart I go from milli to killa, that's 1, 2, 3, 4, 5, 6 to the left. 1, 2, 3, 4, 5, 6. Fill in those 3 missing spaces with zeros. And we get 0.0001 kilograms. Okay. So now we have to convert the other beetle. 25 milligrams equals blank kilograms. 1, 2, 3, 4, 5, 6. Fill in those 4 spaces with zeros. 0.12345 kilograms. Now the problem tells us that our total momentum, so P1, and let's call this guy over here bug 1, and this one bug 2, plus P2 is equal to 0. So our total momentum has to be 0. And it gives us all the information we need to find the momentum of bug 1. We've got his mass and his velocity. So let's do that real fast. Momentum of bug 1 equals mass times velocity of bug 1. Oh, and we're going to have to pick some directions. The problem says beetle 1 has a mass of 100 milligrams and walks in the positive x direction. So this guy is pointed this way, making this positive x according to the problem, meaning the other way has to be negative x. So bug 1's velocity, and therefore his momentum, will be positive. So we decided that's 0.0001 kilograms times negative 0.1 meters per second. And that gives me P1. Oh, wait, we said bug 1's walking positive equals positive 0.00001 kilogram meters per second. So now we need to be able to add that to bug 2's momentum and get 0. So let's write this out. We need P1 plus P2 to equal 0. So we need 0.00001 kilogram meters per second plus the mass times the velocity of bug 2 to equal 0. And we're trying to find what velocity, let's see, what speed must bug B walk to get 0 total momentum. So let's solve this for velocity. I'll move over the term we already have here, and I get mv2 equals negative 0.00001 kilogram meters per second. Okay, that's m2 we need to divide, so let's divide by the mass of bug 2 on both sides, divide by m2, and I get v2 equals negative 0.00001 meters per second divided by the mass of bug 2 was 0.0000025 kilograms. And let's see what I get when I do that division. I get that V2 had to be negative 0.4 meters per second. And I'm going to be really specific here, since we're worried about vectors and not vectors. The problem asks for speed. Speed's not a vector. So if I just get the speed of bug 2, it doesn't need to be negative, 0.4 meters per second, because it asks us for a speed, which is scalar, not a vector. Okay. Hopefully that didn't confuse you. I have this weird equal sign here at the bottom that shouldn't have been here. Yeah. So there's momentum and total momentum. Tomorrow I'll show you how to solve collision problems with momentum. There we go. See ya in class.